Hello, and welcome to this course, Juniper JNCIA Security. We are in Lesson 4 of Chapter 1, and we will discuss the Virtual vSRX appliance. Specifically, you will learn about virtualization, so an overview of virtualization technology. You will learn about public and private clouds. You will learn about software-defined networking, and also the vSRX characteristics and how it is compatible with all the previously mentioned technologies. Let's start by discussing virtualization. So what happened before virtualization existed? Well, you could find a scenario like this. You had a physical server hosting a domain controller. Let's call it domain controller 1. And that physical server would be utilizing the Windows Server software and acting as a domain controller, but its resource utilization probably went up to 40%. So you were spending all the energy, all the space, all what it takes to have a server, to host a server, for only a 40% utilization. Then you had your mail server. And as it turned out, you needed a mail server, but your company was still pretty small, maybe. So the resource utilization of that physical server and its resources to host an email server just went up to 20%. And then you had your payroll system, which again, having not a lot of data on it, it came to a utilization of 15%. I'm guessing by this point, you can see what I mean here. Before virtualization, hosting different servers or different applications in different servers was a waste of energy and money and chassis and a lot of things. Because what happened was each application, each server had to have its independent hardware. So the technology industry, I'm not going to mention any brands, there's a specific brand who did it, but in any case, the technology industry realized this and came up with a solution which is called server virtualization, and this was sort of the beginning of it all. So when you take a server and you virtualize it, what you're doing is you're putting it in the same chassis, so you're using the same hardware that probably you were using for a single application to host maybe the domain controller application. But then when you realize that really, if you added up the 3 servers workload, it didn't go any near to 100%, you realize you can put them all and host them all in the same physical server while maintaining logical identities that are different, so maintaining different servers. The way to do that is by using a special system. We can call it a special operating system called a hypervisor. You can see that in the picture with purple. And the hypervisor, what it would do is it'll manage all the physical resources that you can see below. You can see the hard drive, the memory, CPU, and networking. So the hypervisor will be in charge of pooling those resources and assigning the needed amount of resources to each of the servers. What a great idea, isn't it? So now you have domain controller, mail server, and payroll system living in the same chassis. You're saving a lot of money in hardware, energy, and space. So that's the idea of virtualization. So remember, a key concept that makes this possible is the hypervisor that helps create that abstraction. In reality, each virtual machine is a set of files, of special files that come to life via the magic of virtualization and the resource management of the hypervisor. And it works just like it would work on different servers. Of course, such an environment has its own complexities, and that's why we're going to talk about, for example, how networking works inside of a virtualized environment. So you have a different diagram here where you have the hypervisor, the big sky blue square. You can figure out that's a single chassis. And then again, you have 3 different servers inside of it. Now, those servers might need to communicate to each other, very possibly. So they have a virtual NIC, or network interface card. Just like a computer or a server has a physical interface card attached to its motherboard, the virtual servers have a virtual card that allows them to have connectivity and have a different identity even within the same device. And look at what we have here, a switch. Yes, the same concept that we have in the physical world of Ethernet switches, you can have it inside of a box. So these servers can locally communicate with each other via the switch. And the switch even supports VLANs, just like a normal switch. Okay? Now, some of those switches are provided by the hypervisor vendor. Some of them are additional entities by other vendors. And a key component comes to play here. What if you really wanted to protect traffic coming in and out of that server because of its criticality? Well, you can actually place a virtual SRX firewall from Juniper at the edge. So even within a single device, you would be enforcing security policies, not only in and out of the device, but also, say, if one of the servers belongs to a different security zone, the SRX firewall can enforce security policies across security zones inside of the same chassis. Isn't that beautiful? And those things, having virtual switches, virtual firewalls, virtual routers like the VMX also from Juniper, that's what we call network function virtualization. Now, you have probably heard about the cloud. It's a very widespread computing concept that it's embedded into pretty much every marketing material out there from technology companies. But what does it mean? What does it mean to have a cloud? Well, really, the cloud is an evolution of virtualization. Virtualization made it possible to offer a series of new products and services through virtualized environments in remote data centers. Okay? And that's the cloud. The cloud is really somebody else's computer, somebody else's infrastructure that you are using to provide services to end clients or to companies. Or it could be your own cloud, but it's still a separate entity within a data center that provides your company services. That would be what you call a private cloud. So a private cloud, your company owns it. A public cloud is owned by somebody else, but you're using it and you're paying for the consumption of the services. So what is an important characteristic of the cloud? The cloud takes virtualization to a different level of abstraction. If you've ever used Amazon AWS, for example, or Azure, you can see that there is a wide range of services available to you. Everything is available in menus, and then you choose a particular size of machine, a particular server. You have to wait a little time for provisioning, and boom, magic. You have it. All right? No complicated configuration in the underlying infrastructure. So that's the magic of cloud. It gives you a cloud services catalog, like you can see in the image, and then from that catalog, the user interacts with it, and whatever the user chooses, it's sent to the virtualization software API or application programming interface, so that the virtualization software gives the order, and the resources are added, moved, edited, or provisioned at the data center level, where the actual hardware resources, memory, storage, CPU, software, where everything resides. Okay? So from a user's perspective, is relatively easy because everything is orchestrated. So for that set of commands and orders, and for that to happen that magically, clouds utilize something called orchestration software. And that's what they do. They orchestrate dynamic management, configuration, and deployment of computing resources. Okay? All right, so there is a third concept that is very strong right now, and it's called software-defined networking. So it has a lot to do with cloud and virtualization, but it's different. It's related, but it's different. So what software-defined networking means is typically or traditionally, networking devices are managed in silos. Every networking device is different. You have to administer them, configure them, and manage them separately, which becomes complex. Think about a multi-vendor network. Cisco, Juniper, Aruba, Ubiquiti, a lot of different vendors, a lot of different devices. Something happens, and you gotta go and figure out what it is, and you gotta learn to use all the interfaces for all the devices. It is complex. So with virtualization and cloud, a precedent was set that from a single console, you can orchestrate and manage a lot of servers and computing resources. Well, software-defined networking says, why don't we do that with the network? Why don't we centralize the network intelligence? Think about networking protocols, think about traffic flows, think about even firewalling and security functions, right? Why don't you just centralize it, abstract it via software, and manage it easily across the whole infrastructure? And that is exactly what software-defined networking has proposed. So there is a central intelligence, which is the controller in SDN, and there are forwarding elements, which are the actual network devices dealing with packet movement across the network. In the purest interpretation of software-defined networking model, those forwarders don't have intelligence of their own. They are just, for so to speak, slaves to the controller. They just move stuff in and out, and everything, all of the intelligence is provided by the controller. But as we will soon learn, there have been different interpretations of software-defined networking. Oh, by the way, do you remember control plane and forwarding plane? Yes? Do you remember how Juniper enforces that at the device level? Well, software-defined networking proposes to enforce a control plane and forwarding plane, but at a macro level. Something that spans the whole network, not just a single device. Control plane is centralized. Forwarding plane is a lot of different devices moving packets all around. Okay? So let's see a more detailed example of how software-defined networking works and the different elements. So in the top squares, you see application, orchestration, and OSS/BSS. Application could be a custom application in programming language to apply configurations and programmability to the network. Python, Ruby are typically used. Orchestration can be achieved with multiple different solutions, right? Such as Cloud Stack, such as Chef, for example. Like those are orchestration platforms. Then OSS/BSS are different business servers or services that, for example, take inventory of networks or configuration management, change management, and they can also be connected to the SDN controllers to pull information that is relevant to the network. So those applications are going to be the ones that define and that provide the controller with the instructions of what to do with the network. The controller is the network's brain, right? It's the control plane. So whatever interfaces are used between the controller, orchestration, or OSS/BSS are called northbound interfaces. All right? Those are the interfaces that will provide the orders to the controller on what to do. Controllers also need to be interconnected with each other for clustering and failover. So that interface, or those interfaces that will allow that communication between controllers, is called the east-west interface. Now you can see there is a physical network of forwarders below. we also need interfaces from the controllers to the forwarding network. There you go, a fully meshed one. And those interfaces are called southbound interfaces. Okay? This allows an end user to access the server, as you can see in the picture. It's networking as usual, but not as much, right? It's a different architecture and it's a different way of doing things. So I spoke about the purest form of SDN before, and that is called OpenSDN. It's the original way to implement SDN. It is very disruptive. As I said, network devices have no logic of their own, and there have been very successful deployments of this at very large corporate levels. Of course, it requires a big effort in programming and management and training of the team and everything, because it's very new. And then typically in OpenSDN, the northbound API is REST or is based in Java, and the southbound API is OpenFlow. OpenFlow is a protocol to interact with forwarders, controllers and forwarders. There is another sort of middle ground SDN, which, because it's middle ground, it's more compatible with the traditional model, has had a lot of acceptance, which is called Overlay SDN. And as a matter of fact, Juniper has its own Overlay SDN solution. So what it does is it uses tunneling to communicate across hypervisors. It works with existing network equipment as long as the software has the proper APIs to be programmed centrally. And then the overlay is what we call the abstracted tunnel path, which is defined by software. Remember, software here can define traffic flows that probably were not even possible in traditional networking. Now everything is managed by software, so it's possible. But in Overlay SDN, you need tunnels to achieve that. And then underlay is the traditional network infrastructure. And again, in Overlay SDN, it's configured as in the traditional way. All right, so it's more compatible. It's an easier transition to SDN than what it would be to apply the full open model. And as I said before, Juniper has its own solution, which is called Juniper Contrail. Now, why, you're wondering, are we looking at all of these concepts and architectures in a security class? And the reason for that is the Juniper vSRX. That's the lesson, right? But we needed to provide context to you on what are those technologies that the Juniper vSRX has been created for, what it's being created to address. And the truth is, Juniper vSRX works perfectly well and has been created for virtualization, cloud, and software-defined networking. Right, before we go to the Juniper vSRX strictly, you need to know that in Overlay SDN, there are tunneling protocols. VXLAN, has a very widespread adoption. It's a MAC in IP tunnel. NVGRE is a MAC in IP tunnel using generic routing encapsulation, but it's mostly used by Microsoft solutions. And then MPLS over GRE is the default used by Juniper Contrail. Very much like the abilities that MPLS provides to a service provider to tag different clients or tenants and differentiate traffic with tags. Well, SDN uses the same to enforce multi-tenancy and to differentiate the flows and be able to manage them in an agile way. Okay, let's now talk about the Juniper vSRX. All right, when it comes to features, the vSRX doesn't fall short of the other SRXs. It has support for the full routing protocol image from Juniper, and it can also run advanced security modules. It's got a Linux-based kernel. Its virtual CPUs can be assigned to PFE or RE independently, which is great and part of the flexibility of using virtualization. It has multi-core support for the packet forwarding engine, and it's also capable to run in a high availability cluster mode. In the previous versions of Juniper vSRX, that wasn't possible, but it is possible now. As far as compatibility goes, vSRX is compatible with the VMware ESXi hypervisor, the Linux KVM, and with Microsoft Hyper-V. So it's got very good compatibility. As far as cloud goes, it can be orchestrated using OpenStack, CloudStack, or VMware vCenter. And as far as support to be integrated into public cloud infrastructure, yes, it can also be integrated into Azure and AWS environments. As far as Juniper goes, the vSRX can be managed via Juniper's own solutions, so Junospace and Security Director, and Juniper Contrail, which is the software-defined networking solution from Juniper. The vSRX requirements are very simple. A minimum of 4 GB RAM when it comes to memory. Disk, you would need at least 16 GB, either IDE or SCSI. Then 2 virtual CPUs. And if you're using ESXi, the vSRX will support up to 10 virtual NICs, so 10 virtual interfaces. And if you're using KVN and QEMU images, it will be less, would be up to 6 virtual network interface cards. In this lesson, you have learned about virtualization, about public and private clouds, software-defined networking, the characteristics of the vSRX, and its compatibility. Thank you so much, and for the next and final topic of this chapter, we're going to have a look at the JWeb interface and what are your lab options to start practicing for JNCIA.